On the 5th of January 1993, the engines failed on this oil tanker, the Brea, in the North Atlantic near the Shetland Isles. She was drifting helplessly, force winds and mountainous seas. The weather was so savage, the crew had to be helicoptered to safety. To the dismay of the Shetlanders, even the tugboats could not save the ship. And in the end, she was driven with her cargo of 85,000 tons of oil onto the waiting rocks. As the black oil gushed from the stricken tanker, local wildlife experts feared an environmental disaster. Birds were smothered with oil. Poisoned fish were washed up on the shore to die. The big worry was, how far would the oil spread out? Before you can tackle this disaster scientifically, you have to find out how oil and water behave under controlled conditions. Does water temperature affect the spreading of oil? When you're investigating a complicated problem, it's important to look at one variable at a time. That's why they're using a measured amount of oil. In the warm water, the edges are all smeared out, and the oil slick is 11 centimetres across.
It's 11 centimetres diameter.
In the cold water, the edges are sharper, and the oil spreads out less.
7 centimetres diameter.
But in the Shetlands, the sea is not usually... And to investigate the effect of waves, you need a wave machine.
Wobble this tray so we can get some effect of waves. It's all spreading out. It's spreading even more now. Yeah. Spreading into tiny parts. Yeah. Its own parts. It's split up. It's not all stuck together. Mm-hmm.
What do you think wind will do to the oil?
Does it a lot? No, doesn't it?
Both waves and wind seem to break up the oil into bits. How small do you think the bits can get? Furniture's made of wood. What's wood made of? When a carpenter's shaping a piece of wood, he first cuts off big lumps with a chisel and shavings with a plane. You can see that the shavings are little bits of wood. Sandpaper takes bits off too, but they're much smaller bits. How small is the tiniest possible particle of wood? This school is being worn away. For 440 years, Pupils have been pounding up and down these stairs, and their feet have worn away the stone. Maybe 1,000 feet a day have been up and down these stairs. Is that a reasonable estimate? To get some idea of the size of the particles that make up these stone steps, we sent in the Scientific Eye team.
Find the deepest part of the gap.
They laid a piece of wood across the most worn step and with a scientific eye measured the gap. 4.9 centimetres. About 1,000 feet every day. How many feet in 440 years? And how much stone must each foot have worn away? The Greek philosopher Democritus was the first person to think seriously about how small particles can be. Could he keep on slicing his kebab thinner and thinner forever, or is there a limit? He guessed there must be particles so tiny they could not be sliced anymore. He called them atomos, Greek for indivisible, and he thought everything must be made of these atoms. Water is made of atoms, cats are made of atoms, fire is made of atoms. Whatever happens to these things, the atoms never get destroyed. They just get rearranged to make burnt cats, smoke, and other new things. Think like Democritus. Look at the steam from this kettle. The dark space above the spout must be full of tiny particles of steam, much too small to see, until they come together to make the white cloud. Think like Democritus. How do the flavour and the colour of the tea get out of the bag and into the water?
Clear the site immediately. There is a health hazard from the ship. Please clear the site immediately.
When the Brea went aground, it wasn't just the sea that got polluted. These cabbages were contaminated with oil and had to be thrown away. The sheep would not eat the oily grass and had to have expensive food brought in. Even their wool was covered with oil. How could the oil spread so far? There are other particles that pollute the air. This environmental health officer isn't looking for oil. He's checking on other dangerous particles. This filter paper traps particles of lead, a poisonous metal. And this tube traps particles of nitrogen dioxide, a poisonous gas. All the samples go back to the lab for analysis. One way to find out how many particles were trapped is to dissolve them in water with special chemicals. The deeper the colour, the more nitrogen dioxide there must have been in the air. Lead particles are removed from the filter paper by dissolving in acid. Metal atoms often change the colour of a flame. Bright yellow means that salt contains the metal sodium. This machine is designed to suck in dissolved metals, blow them out into a flame and measure the intensity of the colour. First, dissolved sodium. It should turn the flame yellow. Next, a different metal called lithium, which gives a different colour. Finally, dissolved lead. This time, the colour of the flame does not seem to change, but the machine can spot the difference and works out how much lead there is in the sample. Different materials have different properties. That's because their particles aren't the same. Oil floats on water without mixing. These 5 white lumps look similar, but they're all made of different stuff. What do you guess will happen when they're dropped in the water? Wood, polystyrene, lead, a lump of sugar. You can see it beginning to dissolve in the water. This is a piece of the metal lithium. It's so light, it floats, and so reactive, it attacks the water. How would Democritus have explained what's going on here? And why do you think the 5 lumps behave in such different ways? This is the periodic table of the elements. There are about 100 different kinds of atoms, and everything in the world is made from them. Most elements are metals, silvery grey, but this one is gold. Put enough gold atoms together and you can make a gold ring. Higher up the table and a bit to the left, atoms of iron. Put enough of them together and you get a metal that's heavy and hard and tough. Sometimes different atoms join together to make compounds. 2 atoms of hydrogen and 1 of oxygen make a molecule of H2O, or water. This is an atom of carbon. Carbon atoms can combine with atoms of hydrogen to make molecules called hydrocarbons. There is a huge variety of hydrocarbons, and a complicated mixture of them is what you get in oil. Knowing the properties of oil should help with cleaning up the spill. We often use detergent molecules to help oil and water mix.
Try stirring it.
Still not doing anything.
Detergent molecules dissolve both in oil and in water and seem to help break up the slick.
Yeah. It's not getting rid of it.
But remember how the savage weather in Shetland caused the slick to break up completely.
A bit further.
A bit further down. Into the oil a bit.
Breaking it right down now, isn't it? Trent water all red.
In the end, the particles of oil are too small to see. What happens to the oil molecules as the slick breaks up?
I've broke it up into little bits, hasn't it?
You made it dissolve.
Yeah, so they're so
Standard in
small,
water.
it's just mixed in with water.
After the Brer spill, they sprayed tons of detergent from a plane to try to keep the oil slick off the beaches. But do you think the oil is less dangerous spread out as tiny particles? And what effect would all this detergent have on the birds and the fish? What sort of material might soak up oil off the water's surface? Sawdust? Wood shavings? Straw? Or would you try cat litter?
Gripping it with it, taking it down with it.
If you just wanted to sink the oil, cat litter might be okay, but it would be expensive.
Yeah, it's taking it all down.
What you need is something cheap that floats and absorbs the oil. Natural materials like straw and wood shavings might do the job. In practice, do you think the sea was rough and the wood was wet? Molecules of oil do seem to stick to the wood shavings so that the whole lot can be scooped up. Straw works too, though not quite as well. What about sawdust? How is it different from wood shavings? Why is sawdust so good at absorbing oil molecules? And how might knowing about atoms and molecules help next time an oil tanker hits the rocks?